Alright, today we're going to learn about equation of a straight line. In coordinate geometry, there are many occasions where we have to find the equation of a straight line, and an equation of a straight line is always in the form of y equals to mx plus c. So what does m represent? M represents the gradient and c represents the y-intercept. Now, a good way to start is always to find the gradient first. Once you have found the gradient, you will have to use a coordinate, and that will help you with the y-intercept, which I will show you in a short while. So how are we supposed to find the gradient? Now the simplest way would actually be to use the gradient formula, which is y2 minus y1 over x2 minus x1. Now this is the case where there are two coordinates given, so this is the simplest and the most straightforward way. However, there are occasions where it may be that you do not have two coordinates given, but you have been given some other clues. Like for instance, you may have to borrow it from parallel lines. So when they tell you about parallel lines, one of the things that you have to take note of is that it means that the gradient is the same for the two lines. Or you may have a clue that says that the lines are perpendicular to each other, which means that you can borrow the perpendicular gradient, the gradient of this perpendicular line to find this gradient, and what you have to do is to take the reciprocal and then the opposite sign. Alright, now let's look at an example to see how this can be done. Now if you look at this diagram here, alright, you have AB is parallel to DC. Okay, so you can see that it's actually indicated here. Alright, and AD is actually perpendicular to DC, so you can see the 90 degrees here. So let's go with the first one first. Okay, I want to find the equation of AB. Now remember, for any equation of a straight line, it has to be in the form of y equals to mx plus c. And in this case here, we find that the only coordinate that we have is actually the A coordinate, which is 2, 6. We do not have coordinate B, so we can't use the first formula of y2 minus y1 over x2 minus x1. So this is where we have to use this other strategy, alright? Either borrowing from a parallel line or from a perpendicular line. Now, if you look very carefully here, right, like what I mentioned earlier on, AB is parallel to DC, and DC has this equation which is y equals to half x, which means that this is actually the gradient of DC. Alright, so in this case here, what we can do is that we can say that gradient of AB is the same as the gradient of DC. Alright, parallel lines. So which means that y is equals to half x plus c for the line of AB. And what we can see is that we currently have the gradient. And now the only thing left to find is the y-intercept. So since we have one coordinate, which is coordinate A, that's the only coordinate we have to use. So when x is 2, y is 6. Let's replace it in here. When y is 6, x is 2. And what we will have is that we have 6 equals to 1 plus c. So c will be the same as 6 minus 1, which is equals to 5. And in this case, my equation of AB would be y equals to half x plus 5. So I have the gradient and the intercept. Now, the second one that actually want us to find is the equation of AD. Now remember, it was mentioned that AD is perpendicular to DC. So now that we have the gradient of DC, which is half, right? DC's gradient is half. So I can say that the gradient of AD, okay, the gradient of AD, we will take the reciprocal of this, which is 2, and the opposite sign, which is negative 2. So what we will have is that for AD, y is equals to negative 2x plus c, where this is the perpendicular gradient. Now, again, the only coordinate that passes through AD that we have is actually A again, which is 2, 6. So again, when y is 6, x is 2. and we will have 6 equals to negative 4 plus c. C is the same as 6 plus 4, which is equals to 10, which means that this is the y-intercept, and when we put together to find the equation of AD, this will be y equals to negative 2x plus 10. So that's how we get the equation of lines. One of this, borrowing a parallel gradient, and for this one, borrowing a perpendicular gradient.